change some parameters of that file itself. Voila, you have something else that is weird that is happening. Or maybe try uploading an image, or maybe try uploading, notepad.exe, I'm just saying, but don't do that. Anything else. So just try doing something a bit random that the application should not be actually accepting. Right? If someone says, hey, the image should be less than like 10 megabytes or something like that, try to play around a bit. Your size is a constraint that you have to live with, but you build your test case saying, hey, I'm going to upload an image which is 9.9 megabytes, but while upload, I'll just stop the upload and I'll try to reinitiate the upload multiple times to see how the app behaves. Basically, you're trying to test how the app behaves when you're trying to retransmit. It's something that's a bit of an edge case scenario all the times, but you're only trying to look at what is available to you and try to make it behave a bit different. Now we'll look at a little more cooler demo. This is typically how, let's say this is typically how a login page would look like. Something like this. So how do you generally write your test cases around this? Saying the login page is fine, it's working. So a good username, password combination, and you'd also combine it with bad username, good password, something like that. Yes, you can also look for length. That's cool, that's great. But what if you could do something a little different? I want to type the name, username, admin, works fine, all good. In this case, admin is a password, but bad password scenario, but either way. What I'll do here is, I don't want to type admin as a password, rather I want to do something a bit funky. I would say, hey, do the test as my password, but I'll do some funky stuff, I'll explain myself. So something like this. This is good, right? In this case, I'm printing out the SQL statement. When you look at the password, it says, hey, password is test, but also execute this other part of my query. This is a typical example of a SQL injection, a very basic example. What is happening is select from the database where the username is admin, but try to see if the password is test. If you fail, execute the OR query, right? See 1 equals to 1. 1 is always equal to 1, right? That's pretty basic mathematics. That's how computers operate. But I've just pretty much broken the principle on how the login page is supposed to operate. But what if your test case was actually able to pick this up a bit earlier? You have a very fast feedback into the software development lifecycle. Because the time taken between multiple teams plays a role on how fast your application is developed and deployed. That's one thing. But second, the earlier feedback that you give to your developers, the amount of time that you save is a lot faster. So typically, say when this comes back to in an organization, the developer writes code, it goes through testing cycle, then it comes to security team, then there is this code scanning run or some kind of a scanner that is run, then you have results. Then you're back to square one. Instead, you're cutting short of that and saying, hey, within this 3-week sprint or 2-week sprint, the developer and tester are working together to find some bugs like this. So your test cases would or should include some scenarios of this sort, saying, I want to go a bit beyond, consider all the anti-patterns, the CWEs for injection, and try to see what happens or how the application behaves. We'll look at a quicker, different example. What I'll do here is, instead of the previous injection, I'll try to type something first, test, I'll do single code, I'll do a couple of single quotes here. I want to see what happens or what the application does when I give something very weird. This is pretty weird, right? How many of you have seen applications throw some random errors? Maybe not your app, but some other app. We see this, right? So let's go back to reconnaissance. So if I were to be still doing reconnaissance as part of my testing, I know that this application has a file by name login-1index.php, which means it's giving me some structure how the web application server is. This is information that should not actually be available. So as part of your software testing, you can even cover cases like, hey, this information should not be available to user. Keep it generic. I'm saying something weird. Now all I did here is, along with password, which is some alphabetic characters, I've introduced symbols. Now today I'm not diving into topics like symbolic execution or concolic execution, just to keep the topic simple. Maybe in the future, if we were to come back, I'd definitely do that. The whole idea is try to introduce some symbols, right? Take some ASCII characters, see what happens, how the application behaves when you introduce symbols into input fields. But hey, as part of reconnaissance, I did tell one thing. We are always stuck with this whole idea that, I'm only supposed to test the input fields that are visible. Is that right? You're seeing the username password fields. But what if I told you that there is a different way of looking at inputs? So all I go here is to my browser, no funny tools or nothing. All I'm using is my browser to say edit and resend. Random field. So this is the response. This is the response in this case. Well, we see that you're not limited to what is visible. You have to try to see what is actually hidden behind. Same green padlock situation with Google. What we forget is that your secret is actually not a secret. It's not really private as we assume with the green lock. Same situations with web applications. The input is not what we actually see, but it is something a bit more beyond. So you can introduce inputs almost anywhere in your web application or any application in general. The interaction points are very different because assumption one that we have made in general in our life is that this is the operating surface for me to access a web application. But it's actually not. It's a browser, it's an application that is doing all the funny things, giving you access to things beyond. All we are doing or missing out is what are these things. So that's quickly with the demo there. We have looked at OWASP bricks. Now this is not a project that I've developed or worked on. It's from OWASP, or Open Web Application Security Project. A great resource if you're looking at learning on software testing, security testing, anywhere. Great resource to look at. There are tons of projects under OWASP. One of them is called OWASP Top 10. So cross-site scripting is one of those OWASP Top 10. And there is a reason it's called Top 10. These are the top 10 worrisome things for web applications. It doesn't mean that your application is still good. If you don't have the top 10, there might be something else beyond. But the whole idea behind the demo is to tell you that you have to start looking when you're testing. Just look a little beyond than what is actually presented to you, and that paints a bit different picture about an application. So yeah, but yeah, don't start hacking random websites, I guess. But usually organizations would say, hey, I have a security tool hasn't picked up. But yeah, that's fine. Or they could have some random tools. SAST and DAST are the common ones that we hear in enterprise. They have funny names, which many security kind of hate those words. It's basically, one is a static code analyzer, the other is a dynamic code analyzer. One examines source code, something that is in almost English with a format and spacing and symbols and etc. The other is the actual runtime, like an executable, like a library or something that is a web application, how we were looking at the web application itself. Or basically the previous demo, what we were doing is runtime tests or tasks, basically. Tool can do it, but imagine you were able to talk with this tool and develop your test cases around that to capture more things that the developer, not to make a developer's life hard, but to capture this edge case scenario so that you learn one and you benefit your own organization. That is the goal. And yeah, going back to CWEs again, when you start reading more about it, you would understand the importance of the patterns serving as abuse cases or anti-patterns. So basically, imagine that you have a list of 300 items that you're trying to test against. And these 300 items could potentially break the application, and most of them being security related vulnerabilities. The only difference is you're catching it very early in the software development lifecycle. Now, post-exploitation, I've skipped it as part of this demo to keep it a bit simple. In security, what post-exploitation means is, hey, I've been able to break into this application in the previous application. I want to do a bit more. I want to actually install a backdoor, disable the antivirus, do a lot more, extract useful information, things of that sort. But in software testing, probably we don't do that. There is no exploitation. There is only feedback to a developer. So that's pretty much the difference there. Of course, we're not doing reporting today, but if you're happy with reporting, we have the demo applications. But there is always this curiosity that drives us each day, right? I want to do something more. Like you didn't stop, when you were born, you were crying, and after a few weeks, someone figured out to make funny noises. A couple months later, you start walking, right? Did you give up? Like I'm crawling, I'm fine, or I want to start walking. We all have this curiosity to see how we want to walk forward, we want to move forward, we want to always do something bit beyond. Same in case of security. Hey, we're looking at web apps, but how about my real life, or what happens in the real world? This is just as a quick disclaimer, of course, but a quick thing saying that there are things that we can look around on how we can gain trust rather than just the green padlock. So security headers. So what I did previously in the application is I included my own header as part of a web application. Right away, the web application, if it was designed well, would just reject away and saying, hey, I don't want to respond to you, you're behaving funny. But security headers, I'll slowly explain this. In this case, it's CNN.com. I've randomly picked a site. Doesn't mean you go to this website and start scanning everybody today. But the goal is to say, hey, this is the web application that I'm trying to deploy. This is my organization. I care for it. What do these things mean for me? So these are things that you can actually target early on as part of your software development, to include them as test cases or to capture them early on to say that, hey, these are the things that are missing in my application, so we might lose trust of people. So in this case, CNN, quickly explain what one here strict transport security means is, if someone were to suppose say make a go visit a news channel page on CNN, the potential for an attacker to influence that, hey, don't go to HTTPS, just visit HTTP, is very likely. So the likelihood becomes very real. Now imagine if this was not CNN, but rather one of the banks that we picked earlier, NAB or ANZ. It's a very, very different, very weird scenario. You don't want to go over HTTP because HTTP is secure, right? That's the feedback that you guys gave me early on in the session. So I'll ask you on that. Similarly, each option means the same. And what these settings actually mean is you're influencing the behavior of a browser if it's a web application. This is exactly how your application should behave. If you're clicking on an ad and coming from some funny source, not allowed to do that. Or imagine you open, my bank, my really good bank.com on one tab of your browser. Now the other tab you visit Facebook, and there is a malware or malicious ad on Facebook. So once you use this ad and you follow the link, click and get funny pages after that, what ends up happening is there is a malware alert on your machine. So has anyone come across such a scenario where you visit a website and your antivirus is all the way throwing out alerts? No? Never? We have, I think most of us are shy. Let's be a bit honest about that. It happens once in a while. Or otherwise we see annoying pop-ups come in, right? We don't ever examine or we don't question why these happen. Rather we just accept them and say, hey, I have a pop-up blocker, or hey, I'm just going to click OK, or just close this off and run away. But imagine those websites and you have your banking application open at the same time in a different tab. That website or that advertisement itself could influence what you're doing on a different tab. So that's the reason why you want to examine this as you're testing artifacts early on. And these give feedback to a developer saying, okay, this makes sense to me. I want to make my app more secure, or I want to do this. These are best practices or something of that sort. Well, I did put up an audience choice, but I would encourage you guys to go ahead and visit the website. Pick up your favorite bank or favorite news channel, see what's going on, gain trust that way, and switch over to a different bank. No, I didn't say that. Right, but sometimes pen testing is not cool. Software testing is cool because you're giving feedback to developers to make sure applications actually work, right? But pen testing is not the same. So just this is where I'm saying this disclaimer. So this is a traffic camera somewhere in Oslo, Norway, somewhere Norwegian country. It's a bit scary, right? because I have access to it, or anyone on the internet has access to this camera. But if I were to flip this saying this is the camera just outside your house or inside your house, it becomes a bit scary, right? Is it? Well, we don't want that, right? So that's why sometimes pen testing is cool, but not really. But I have a few more, of course. Don't ask questions on like, why am I doing this? Why am I getting all this information? Huh? At least you'll have to trust me on that part. But this is information that is available. If I were to be doing reconnaissance on, say, hey, what are the webcams that are available on the internet? Give me a list of it. Let me see what people are doing. It's creepy. It's creepy. But this is just saying that, hey, a small list of people who have just left their cameras open. They have completely, probably, they're not aware. They're not tech-savvy people. But I want to make a difference. Try to contact these people and say, hey, this is going on. You should do something. And worse, there sometimes you see people with their cameras, they leave open inside the house. Usually, working couple, they have children at house or old people that they want to take care of. They leave cameras on. And imagine the same username password scenario that is stopping someone from accessing a camera. Now, what if this page itself is broken? I'm not saying you to go ahead and look for pages like this and break into the camera and do SQL injection, but this is real life. This is real life, and that's why sometimes pen testing is probably not cool, or if you go on the dark side of pen testing, or ethical hacking, or all that crazy stuff, it's not really cool because you're actually affecting real life. And that's why these statistics from the Australian government exist. Now, how do you contribute? How do you contribute to yourself, not to me, not to anybody else, not to Linux Foundation, not to open source, but just for yourself? Is you'll have to write better unit tests if you're a developer, because certain times the scenario is like this. If this is a traffic cam, that is fine. But if not, think in the angle of who is using your applications, who use your applications. The main assumption that we have is, hey, the visitors who visit my applications are genuine people. If you're a financial organization, the assumption that we make first is that genuine people are going to visit. But the reality is you have a lot of bots that visit your website, web application. That is the reason the developer has to write better test cases. That is where you can start building automated test cases, test suites based on CWEs, saying here are the anti-patterns that the software should be behaving well against. I don't want SQL injection, I don't want cross-site scripting, I don't want uploads to behave funny or where a malicious actor can take advantage of. So that's exactly where I want to say that, software testing is important, but you guys are just kind of like, visiting the surface of your role. Start looking at security testing as just to broaden it out a bit. That's pretty much all, guys.